Hello, everyone. Welcome to this short recap of the webinar we held together with the Nairobi Convention in December. I will take you through the main items and let's get on with it. So let me share my screen. There we go. Okay. So when you get into the platform, this is what meets you. Here you can read more about us. There's an FAQ section, etc. But we will head over to the platform. The Ocean Data Platform has three main buckets. It's the public catalog, where you can find and explore and download and access data. It's your own data space, where you can also collaborate on data and decide who gets to have access. And it's the workspaces. If you see these two as grayed out, it means you have not yet signed in. You easily go up and create a free account. Let's go into the catalog. So on the very top here, you find already a useful data set. Today, we're going to look at some marine protected area data, as well as some habitat data, and have a small fictive collaborative project, how to start aggregating that data in a useful way. Now, let's have a look what a data set looks like on the platform. When you go into data set, they can belong to a collection, which this one does. Here is just one way to group the data and give you some additional information. And then you will find an ID that you can use to connect to the data. And there is something called OGC features, which allows you to stream this data into your QGIS or ArcGIS, if that's what you want to do. So here is the information. And then already at this level, we can get some information about what's in here. We see that there are 20,000 rows and that there are 87 columns with information. We can also decide to export the whole data set as an open source format. When you have a look then at these tables, let's zoom over to something interesting, leveling and fishing protection of these marine protected areas. You can read what this column is about, and you can see some statistics about what's inside. Okay. Now, if we hit over to the Explore table, we'll do that. Then you'll get to this view, and here you can actually filter and work with the data, again, without doing any coding. So we're going to apply a spatial filter. The area of interest today is going to be a fictive cross-collaboration project across the Mozambique Channel. We'll create a little boundary box for that. We can also filter on any of those categories inside. Let's pick an easy one. Okay, we're going to choose marine protected areas. And then when we apply those filters, it will go to the master table and fetch just the data you want. Nice. So here are our protected areas that we want to work more with. And we can decide to export them as any of these open source formats, and we can bring them into our My Data space. Now, before we head over to there, let's have another look at some data on the platform. If we create a spatial filter and we do some search, we find specific data for this area of interest. I search for corals and I find some large coral data sets that are global. Here, the Allen Coral Atlas, we want to work with that one. And I also find WCMC data. But here, there could also be a number of more national or regional local data sets if they are in the public catalog. But you can also search for your private data in case you have data in that area that is not shared on the platform. Again, if we hit over to this one, the same kind of information exists, but also some supporting files. So sometimes the raw file sit here if you want to access it before it was ingested to the platform sort of custom format. And you can also then find supporting information, in this case, the documentation about this data set. Okay, so again, we're going to grab that data the same way as I just did. To save us some time, I'm going to shoot over to another data set that is quite interesting. We have seafloor substrates if you're into just general habitats for your MPAs. And again, here you find a number of data sets and also actually the sample locations that was used to create the models. This data, as an example, I'll show you what it looks like in QGIS. Here we can visualize those rasters quite nicely, and also then stream in the data from the platform with OGC features, which works quite nice for these sample data. Okay, just a last data set I want to show that we're still working on to make available on the platform. But this one is the OBIS data from hosted by IC UNESCO, and this one has 246 million rows of species observations in it. So I actually filtered that for some coral data that I thought was interesting, and I brought them into our shared project. Now, when we go to your My Data section, you can decide to have the data in your data collections or just watch the individual data sets. I created a collection for the demo today, so that's what I've got here. Oh, that's not, let's see what happened. Ah, there we are. Okay, so here are our collection, and we can decide who gets to access it. So my collaborator today, Tom, has access. He's currently on Christmas vacation, so I'm going to play his role for him. But me and Tom are working on this collection together. Of course, we could have added groups and many collaborators here to be able to view this data. Then the actual data sets that we have created, and it's as simple as create a new data set, give it a name, just brief information, and it will be created. Then you can upload the files and you can decide who gets access. You can create a public sharing link, and you can request to publish it if you want it in the catalog. And then you add all the appropriate metadata that you may want. I don't want this one, I'm going to delete it. Okay, nice. So I've gathered some coral reef data for us, and I've actually uploaded a little bit of my own data. So we have a data set from the African Marine Atlas that was used in the WIO Symphony project. It's not yet on the catalog. It's missing some metadata, but for the purpose of this project, I brought it in, and I brought in that coral that OBIS subset as well. Let's just have a look what that looks like. It's 3,000 rows. We can explore it, and here are the observations of crop rock corals in the area of interest. It's quite nice. Okay, great. So what we're gonna do next, we're gonna go and we're gonna join these data so that we have one coral map that we can start understanding what extent of coral reefs are protected and which ones are not. Now, before we actually go into how to do that, I want to show you something we did globally to start playing with this. We have a function on the platform that allows you to group data on these hexagons, and you can choose the resolution. And that's what we did for coral reefs at the global scale. The nice thing with hexagons is that they stay within the same sort of cover regardless of where you are on the globe. Here we did presence of corals, and then we made a simple model to tell us where could corals be, but we do not have a map. Okay, and then you can do that and stack lots of data. That might be useful in your MSP or your MPA project or what it is. Okay, so I'm going to the place where you hit just workspaces, and in my workspace, you'll be greeted with something like this, and you can choose what environment to spin up. The main ones is Python and R, two open source languages used by spatial scientists and scientists in general. We also have this nice little open GIS project that allows you to do some GIS functions directly in the cloud. Okay, so today we don't have time to go through the code, but what we are doing is we are connecting to the platform programmatically, and we made that little nice bounding box. I've actually plotted it here on the GIS map, so this is the area of interest that I made. I used that box with that little ID I showed you to grab the data. And here I'm printing two of the data sets on the map if I would actually print a very large data set like Alan Coral Atlas, it may not work because it is so complex and we're bringing data away from the platform, which means we're still moving data around and you have to be a bit careful with that. Now, for African Marine Atlas and WCMC, that worked nicely, and we can actually even have a look here in the data set. Now, what happens, of course, is that different maps have different coverage, and we want to have one map to rule them all, and ideally, we want to know what is the source in every location. We might want to bring in those OBIS coral observations that I extracted as well and say, hey, if there is an observation outside of the map, I want that to be in my final product. And in fact, we also had the Alan Coral Atlas, but I'll come back to that. So what we are doing here, we're aggregating the data using some functionality on the server side. That means server side of Ocean Data Platform. Simply put, that means that the compute is not happening in your local environment, taking away the need for expensive data infrastructure for those operations and to move big data around. So here we can simply run some code. We set the resolution we want. In this one, I chose about 1 square kilometer resolution, but we could have gone down all the way to 1 meter if we wanted to. It doesn't fully make sense for this data, but we could do it. And then we can run that aggregation, and it's pretty fast. You'll see it in a few seconds. We've actually aggregated that data onto the hexagons to say, is there a polygon or not with coral reefs? And we would do the same. Now, the resulting map looks something like this. We can even open it in a large window. So this shows you a hexagon instead of those more complex habitat features. And this, in this case, let's assume we're doing our marine spatial planning based on that sort of planning unit. And then we can start aggregating more data of that kind. Now, we have one more data set, and I left that out on purpose because I'm going to play Tom. Tom today is on holiday, so I'll put on my Christmas hat. We'll head over to Tom's code. And he had the same code, but in its own environment. It would not have had to be in our workspaces for this purpose. Today, I have it here. So he's pulling in Alan Coral Atlas, and he's aggregating Alan Coral Atlas in his own environment. And then what he's doing is he's pushing that code to the same data set that I did. Actually, I missed showing you, but what I did before I started this exercise, I created an empty data set on ODP. And then I copied that ID here. I added any metadata. I added Tom as my collaborator. See, he's here. It's an editor. He can write this data. And then we are both pushing information. I did it first. I pushed it to this table, and we can go in and explore it. And when I ran Tom's code, it added columns and rows with more information so that we actually now have Alan Coral Atlas as well as WCMC in here and the other data sources I just showed you. So now we can, the same as with other data sets, we can explore them here in the viewer. Let's have a look at that. Let's see, where are we? We're on the Mozambique side. Okay, so if we click on one of those polygons, you can see what's the source of coral reefs inside that coral that polygon. Of course, we can bring this whole data set out to a different place. Maybe we want to work with it in a special app. Sorry, Tom, I'm going to take that hat off. Thank you for the help, Tom. Anyway, we can work with that data in many different places, but here it's just a first way to start exploring the final result on ODP. If that was actually something ready to be published, we could have gone here to request to publish that data for everyone to use it. Okay, so just a final feature to show you. The platform also have support for something called vector tiles. Now, this is the data set that I showed you before with the marine protected areas that we want to use together with our coral reef dataset and many other data sets. Now, the nice thing with the vector tiles, it shows you all of the data, but allows you to zoom in and out even for large data sets. It's a feature we're still optimizing, so and then it will be integrated in the Ocean Data Platform. And here we can see, support for multi-layers and more JS functionality, which is on the way. And in fact, that was actually the end of the demo today. I will just, for those who are been working with me previously when I was in my role with the Swedish government, we also had the example of the WIO Symphony project that is hosted by the Nairobi Convention. Just to give you an example, this is an example of an app that is bringing a lot of similar kind of data together for a specific purpose, in this case, cumulative impact assessment and scenario planning. So it has many of those kind of data sets standardized. And if we have a look at the coral reef data, it has a lot of different sources to it. There's some metadata and there's many sources. Essentially doing what we just did today, aggregating data on a standard unit. So this is the kind of sort of application your data could be feeding, but what this application doesn't do itself is to help you generate those fundamental layers that is powering this specific tool. Great. So again, thank you very much for bearing with me on this recap of the Ocean Data Platform and how it can be used for marine spatial planning and marine science. Thank you very much. And for those who go on holidays, enjoy those. I'm certainly going to enjoy mine.